All right, good evening, ladies. It is kind of late. I am still at school because I am making you a video, and we're going to do this one quickly. So, unit circle is still important. Also, really important that you could quickly think about secant, tangent, cosecant, or cotangent values of anything here on the unit circle with our 6 trig functions and unit circle angles, the special angles. They really just have to become automatic. Think about that, review that. But more exciting, back to SOHCAHTOA, this thing here that you know so well. As I said before, there is there is the reciprocal of sine, the cosecant. So you can think about the cosecant of angle B, which would be hypotenuse over opposite. You can think about the reciprocal of cosine, the secant of B, which would be hypotenuse over adjacent. We'll do a capital A. You could think of the cotangent of B, where, again, the reciprocal of the tangent, adjacent over opposite. Again, those are important. This is a pretty easy review. It's all about word problems. It's all about the application of the sine, cosine, and tangent. And so let's take a look. Big words, big geometry terms. We have the angle of elevation and the angle of depression. So here's my example. Let's say we have a lighthouse on top of a cliff. So here is the lighthouse on top of a cliff, and the little house, lighthouse, okay, shining a light. And you're standing up here on the lighthouse, and you see down below in the sea your best friend, your Beffel, your BFF for life, in a boat. And your best friend for life is on a sailboat down here. And you see your best friend, and your best friend sees you. So you are looking down. We'll do this in a different color. You are looking down at your best friend. And your best friend is looking, oh, I'm going to miss it. And your best friend's looking right back at you. Okay, that line right there, right into each other's eyes. Okay, think about a horizontal line directly out from your sight, whether you're on the lighthouse or your best friend, a horizontal line directly from your sight. Okay, we have an angle right here. We'll call it theta. We have an angle right here, which would be the same angle. Going back to geometry, parallel lines, horizontal. These are alternate interior angles. For your best friend who's on the boat, this is called the angle of elevation. And for you, this is called the angle of depression. Again, angle of elevation, angle of depression, just phrases. Angle of elevation, that's looking up. Angle of depression, that's looking down. Just words you might hear. What's important is between the same two objects, whether it's you in the lighthouse or your friend on the boat, the angle of elevation and depression are the same. They're congruent. Now that's different than, say, we have some bird up here that squawks, and you look up, you see this bird, and you change where you're looking, and now you look at this bird, and that bird looks back at you. Oh, I am the worst. I'm sorry. And this app I'm using doesn't have a nice erase feature. Sorry. Now we have a different angle. Just use a different letter. Let's call this angle alpha. You are looking up. That's an angle of elevation. That's different, but it is congruent to the bird's angle of depression right here, which would also be alpha. Terrible pictures, I know, but just that you get the language. Okay, so classic example here. Let's talk about Mount Rainier. Mount Rainier is 14,411 feet high. So I'm going to draw a mountain here. This is my crude drawing of Mount Rainier. I am in Tacoma, and I am making all this up except the height of Mount Rainier. I look up to the top of Mount Rainier, and I conclude that the angle of elevation of which I'm looking at is, I don't know, let's say, I'm just going to make up an angle, let's say 10 degrees. And I know that Mount Rainier is 14,411 feet. I could use that information to create a right triangle. Let's assume that my eyeball is on the ground for this example. This is 10 degrees. I know this is 14,411 feet, and I could find the distance I am from the base of Mount Rainier, called x. So I think about what trig function uses this angle, this side here, and this side here. That's the opposite side from me. That's the adjacent side to me. So I would say that the tangent of 10 degrees equals 14,411 divided by x. Just solving that, multiplying both sides by x, that gives you x tangent 10 degrees equals 14,411. Then dividing by the tangent of 10, I get that x is equal to 14,411 divided by the tangent of 10. You do that on a calculator, but you make sure that you are in degree mode. So give me just a second. I don't have my fancy calculator, so I'll try to do this on my iPhone. I say 10, and then I do tangent. That's the tangent of 10. I take the reciprocal of that. No, not yet. I divide that by 14,411. And now I take the reciprocal of that. So I got about 81,729 feet. 81,728, or 28.8 feet. I'm going to divide that by 5,280, and apparently that's when I'm 15 miles from the base. So obviously my made-up angle of 10 degrees was much too large for Tacoma. We are more than 15 miles from Mount Rainier, the base of Mount Rainier, but anyway, something like that. Cool. All right, that's it for tonight. Word problems tomorrow in class using right triangle trig. Should be pretty straightforward. Have a good night. Peace. Okay, I forgot about something. One more type of problem would be that I tell you that the sine of theta is equal to 3/5, and theta is between pi and pi halves. So, important things. The sine of theta is 3/5. That does not give us a triangle, but it gives us the ratios of sides of a triangle, which is just as good for this question. The angle is super important. They're telling you that this is in the second quadrant. So I draw my triangle this way. I draw theta in the second quadrant, and I make a right triangle with the x-axis, and I put theta right here, and here's the y-axis. I know that the sine of theta is 3/5. This is theta, but I can use this acute angle right here, and I can say that this is 3 and this is 5, and this is 4, but if I want to get the problem right, I say -4. And that's probably the biggest mistake kids will make here, is not thinking about this side actually being a negative x value, so we put a negative there. Tips: always make the hypotenuse positive. and the xy coordinates will take care of the positive, negative, SIGN signs. Once we know that, it's easy to find everything else. The cosine of theta would be -4/5, adjacent over hypotenuse. The tangent of theta would be 3/-4, which is the same as -3/4, or -3/4. We just don't put the negative in the denominator. It's bad form. The cosecant, we actually could have found the cosecant without any work, right? Because the cosecant is the reciprocal of the sine. So we could have said that the cosecant of theta is equal to 5/3. You can find that with no work, just knowing the reciprocal relationships. Over here, once you get these two, cotangent of theta would be the reciprocal of tangent, which is -4/3. Again, we always put the negative in the numerator or off to the side, but never in the denominator. And the secant of theta would be the reciprocal of the cosine, which would be -5/4. So, sorry about making the video a little bit longer, but if you know any trig function and you know where the angle is, you should be able to find all other trig functions from there. Good? That should be enough. All right. Have a good night. Peace.